Express 5 radical 3x cubed minus 2 radical 27x cubed in simplest radical form. Okay, so these two terms are being subtracted, right? So in order for us to actually subtract these, we would have to have what's under the radical be exactly the same thing. For example, if you have, actually radicals work a lot like variables. So if you have something like 2x minus y, you can't do it. But if you have something like 2x minus x, you can do it, because you're dealing with apples and apples, right? They're both x, so this is just x. It's the same with radicals. So if you have 3 root 2 minus 2 root 2, you can actually subtract those because they both have the same thing under the radical. So this would just be 1 root 2. So the name of the game here is to look at what's under the radical. We have 3x cubed in this case, and we have 27x cubed in this case, and say, hey, how can we make those the same? And the way to do it is to factor out of this one. Instead of this being 27x cubed, we want it to be 3x cubed. So what do we have to take out? We have to take out radical 9, right? So I'm going to rewrite this. I'm going to say, I'm going to keep the first one just the way it is, 5 radical 3x cubed minus 2, but now I'm going to take out radical 9. Radical 9 times, excuse me, times 3x cubed. And now we've made those the same. But now we have this radical 9 out here. Well, what is radical 9? Radical 9 is just 3. So this is all the same. 3x cubed minus 2 times radical 9. And radical 9 is 3, so minus 2 times 3 is 6, right? So minus 6 times 3x cubed under root. Alright, so now we have this scenario where we have the same thing under root. We can actually go ahead and do the subtraction. So 5 times this thing that's under root minus 6 times the same thing under root is just minus 1 times that thing. So I won't even write the 1, I'll just write minus 3x cubed under root. So that's all that equals. We're still not done because this isn't as simplified as it could be. We're taking the square root of something and we have x cubed. So we could separate this x cubed into x and x squared. So that's exactly what we'll do in the next step. Let's make this root 3 times root x times root x squared. So now notice what we've done. We've separated this, what's under the root. Really, x cubed is x times x times x, right? So we can write what's under here as 3 times x times x times x. And we can break that up into individual radicals. It's totally okay to do this, as long as if we were to multiply it back, we would be able to come right back to what we have here, and we would. This is square root of 3 times square root of x times square root of x squared. But there's a reason why we did this, of course, and the reason is right here. We can take the square root of x and get something that's rational instead of irrational. Square root of x squared is just x. So I'm going to bring that to the front, put the rational part first. That's the square root of x squared is just x. And then these two, root 3 and root x, I'm going to bring those back together under the same radical again. Why not? 3x. And that's the final answer. Minus x times radical 3x. This is the rational part. This is the irrational part. That's it.